Yeah, hi everyone. Welcome to the first live session of getting started with competitive programming course. So this time, actually, Professor Neil Dara is not available to interact with you due to some reasons. So me, I am Atul Pratap Singh, instructor of IIT Madras, and we have two TAs, Sahil and Satvik. Will conduct the live session during this course. Okay. Okay. So we have received some queries. So I'll just consider this query first. Yeah, so one is Kuneet Reddy have sent one query. I am BTech first year student. I just know C language. So can I join this session without much knowledge? Okay, definitely. If you are a BTech first year or UG first year student, definitely you will face some difficulty because actually the this course is prerequisite is data structure and algorithm. So some pre knowledge of data structure and algorithm is required. Uh, but basically, we are also defining some algorithms in the lecture video. So if you are very new for this terms, data structure and algorithm, you can get some idea. So initially, if you are a first year student of the UG course, definitely you will face some difficulty uh, uh, to solve the programming question and to understand the programming problems using these algorithms like graph, trees, and greedy algorithm, dynamic algorithm. These are very uh, new term. So you will definitely will face the difficulty to understand these terms. And another query is Brahmajit Ray. Okay, so I often writing code considering uh, all the edge test case that comes to my mind. The code also passes all the public test case, but fails whenever it gets get to private test case. Yeah, Brahmajit is also available in the meeting. So yeah, definitely. So if private test case is not passing for any problem, so definitely you are missing something. You are missing any one corner or one two corner cases. So the basic thing is that read the problem statement carefully. Okay, and just create your own test case. A small size test case you can create for the problem statement where the all corner case should be there, and just test your solution code on that test cases. So sometimes the all corner case are not possible in the public test case. So some corner case will be available in the private test case. So definitely just try to create your own test case to cover all the edge corner case. And another query is B3 pancake flipping. Please explain optimized solution a little more details. Okay, so this is related to the B3. So B3 is related to the greedy algorithm. So I think ma'am is explained in very well way using the graphical structure of the cookies and flipping all these things. So just watch the video once again in the slower mode, and definitely this is very easy problem. You will get the solution. Okay, so if anyone have any query before starting, so the basic purpose to conduct this session is we will discuss the solution of the every week. So now the week 1 and week 2 deadline is over. So we will discuss the graded programming solution of week 1 and week 2 in this session. So we will conduct this session every week after deadline is over for every week. So this time we are conducting this session for week 1 and week 2. Okay, so maybe in the upcoming Saturday, we will conduct a new session for week 3 programming assignments. So before starting the programming assignment solution of week 1 and week 2, if you have any query, if you have any question related to the course, you can ask. Yeah, is there any query? You can raise your hand. Okay. Okay, so we will start from the week 1 programming assignments. Let me share my screen. One second. My screen is visible. Can anyone confirm my screen is visible?
Yes, sir.
Okay, thanks. Yeah, so this is the first problem of week 1, and we will understand the what is the problem statement. So I'll just read the statement once quickly. Rohan has an array of integer a1, a2, and an of size n. Each integer at index denotes the money placed at the index I. He can do the following operation exactly once. Pick a subsequent of the array and cyclically rotate it in the clockwise direction by any amount. Pick integer L and R such that this there is range is given, and rotate the array in that way in the clockwise direction by any amount of time. Rohan wants the maximum amount of money by performing this particular operation exactly once. After performing the operation, Rohan will collect an minus a1 amount of money. So some condition are given. So for example, some test case is also given. I'll just explain with the some test case. So in the sample input, there are 2 test cases given. Okay. So what is the problem statement? We will understand the problem statement first. Okay. So what question is given basically? So we have one list. So there are some elements in the list. So like 1, 9, 8, 4, 6. Okay. So there are position is also given. So 1, 2, 3, 4, 5. These are the position. Okay. So now there is one operation is given. We can rotate the list, complete list or sub list in the clockwise direction. Okay, in that way. So for example, we can rotate this list in the clockwise direction completely. So we can rotate in that way. So after one rotation, our list will become, so this 6 will come at the first position and this one will be shifted on the right. Okay. So now the after one rotation of the completion complete list, we will get 6, 1, 9, 8, 4. Okay, this type of list. So this is the meaning of cyclic rotation in the clockwise direction. And same times we can also rotate the sub list. So for example, if we have this list, so we can also rotate any sub part of the list in the clockwise direction. Okay, so for example, if we apply the one clockwise rotation on this part, so we will get the element in that way. Okay, so we will just shift 6, it will come here. So it will become like 6, 8, 4. Okay, so in that way we can rotate. So this operation we can perform on the list. What is our aim? What is the required output? So after performing these operations, so we will, in the final things, we will just check the difference between last element and the first element. Okay, so an minus a1. So how we can rotate this list in that way? So we will get the maximum value of this an minus a1. Okay, so an is the last element and a1 is the first element. Okay, so this is the problem statement and how we can perform this. So how we can solve this? What will be the logic for this? So first we will identify that what are the position where the element can come of the last element and the first element can come in the list. Okay, so there is one position, for example, we have these elements. I'm just writing again. 1, 9, 8, 4, 6. Okay, so we will identify the all possibility where the elements can come at the last position and the first position. Okay, so we will identify the all possibility of the finding out the maximum difference between an minus a1. So we will just check the, for example, if we are selecting this element, okay, so if we are considering that this is a maximum element, okay, in the remaining side we will find out the minimum element. Okay, so what is the minimum element, what is the position of minimum element in the remaining part of on the left side. Okay, so we are considering that this is an, and in the remaining part we will just check the what is the minimum element and what is the position of that. So you can find out that here this is the minimum element. Okay, so there is no need to rotate this list. But for example, if we are getting a minimum element at the middle position like this, 9, 1, 8, 4, okay, and this is a 6. So at that time we are considering that this is a maximum element, and in this side we will find out the minimum element. So this is the position of minimum element. So after finding out the minimum element position, we can simply rotate that part and we can shift this minimum element to the first position. Okay, so we can simply rotate this part in a clockwise direction. So we will get this 1, 9, 8, 4, 6. After that we can simply subtract this 6 minus 1. Okay, so this is the first possibility with respect to the last element. Okay, so our main goal here is we want to shift the minimum element at this first position and the maximum element at the last position. If we can do this by the rotation, by the clockwise rotation, so we will perform this operation. So this is the first step. Second step is this is the one possibility. Okay, and next is 1, 9, 8, 4, 6. 1, 9, 8, 4, 6. 1, 9, 8, 4, 6. Now second thing we will try for, if we are selecting this as a minimum element, okay, we are considering that this is the minimum element, and we will select the maximum element from this side. What is the position of maximum element from this side? So here you can find out that this is the one possible, this is a maximum. So we can apply the clockwise rotation on this part, and we can easily shift this 9 at the last position. Okay, so here this is 1, and we can simply rotate sometimes. So we will get 6, and then 4, then 8, and then 9. Okay, after 3 rotation. So this 9 will shift it here. Okay, so this is the second possibility. So here we are getting the difference 9 minus 1. This is 8. In the previous steps, 6 minus 1, we are getting 5. Okay, so there are two possible conditions we have checked, and the remaining condition is that so for example we will check the whole list, and so okay, so what element can come on the first position and last position after rotating. So here you can see that every adjacent elements, if we rotate the list, every adjacent element can become, so on the right side this element can become on the first position, and the previous one element can become on the last position. So after some rotation, so for example, if I want to check for these pair, okay, so I can simply shift in that way. So 1, 6, 4, sorry, 6, and then 4, and then 1, 9, 8. Okay, 2 times I have shifted this, and after that you can see these two adjacent element. So the right side element in the every pair of right side element in the adjacent element will be come at the first position after one more rotation. Okay, so 4, 6, and this is 8, then 1, 9. Okay, so that means we can also check for the difference between each adjacent elements, because we can we can shifted these each adjacent element into a last and first position after some rotations. So here you can find the difference between 9 and 8. This is 9 minus 8 is 1. Okay, yeah. So same things we can apply with the each adjacent elements. We can check for the each adjacent. So there is no need to shift each element. We will simply check the difference between each adjacent, what we are getting. So just check the difference between the first element and the second element. So what is the difference between 4 minus 6? What is the difference between 6 minus 8, 1? What is the difference between 1 and 9? And what is the difference between 8 and 4? Because each adjacent we can shift in that way after rotation. So the right side element will come at the first position and the left element will come at the last position. So these are the possibility, and finally we can return the maximum of all these three possibility. The first is this one. If we are considering the last element at the max and checking for the minimum element in the left part, and second possibility is the if we are considering that this is a minimum. Okay, so this is a minimum, and we will find out the maximum, and we can simply rotate that maximum element at the last position. So this is the next. So previous is 5. Next one is the 8, and we will just check the difference between each adjacent. Okay, so each adjacent means simply 8 minus 4 and 4 minus 6, 6 minus 1, and 1 minus 9. What are the difference between all of these? Okay, so this is 4, this is negative, this is negative, this is 4 and 6. Yes, 4 minus 6 is minus 2, 6 minus 1 is 5, and 1 minus 9 is minus 8. Okay, so what is the maximum value among all these? Okay, so this is 4. Now we are getting 3 maximum, 3 value. For the first condition we are getting 5, second condition we are getting 8, and third condition we are getting this 4, and we will return the max of all these. So 4, 5, 8, and 10. Okay, so answer is the 8 for this question. So this is the logic to solve the first problem. I've just so the code for this. Yeah. So I'm explaining in the Python language because I am comfortable in the Python. So you can simply change the logic in the other programming language if you are comfortable in the other language. Okay. So here after getting the input, okay, if n equal to 1, answer dot append. So this is we are calculating the answer for the each test case using this loop. If n equal to 1, so there is no difference. We are returning 0 and continuing. So this is the first case which I have mentioned. We are just mentioning the last element as a maximum element minus we are finding out the minimum position. We are finding out the minimum element in the remaining left part. Okay, and what is the difference between the last element and the minimum element? Okay, second possible answer is if we are considering that the last position element is this. Sorry, yeah, first element, first position element is this A0, and we are finding out the maximum of the remaining right part after the first element. Okay, so this is the second possible answer, and the third one is we are checking the answer for each adjacent value. Initially we are initializing with the least infinite value, and for I in range we are just comparing the each adjacent value. So okay, this is the previous left value, this is the right value, left minus right, and we are finding out the maximum of all adjacent. And after calculating all these three values, we will return the maximum of all the value as the answer. So this is the logic of the first programming assignment, the week 1. Okay, but we have to rotate it only once. Yeah, so we will reiterate only once time after finding out the okay, three so much, yes, okay, yes, sorry. Okay, yes, Evapidi, I'm just explaining again. So how we are calculating the answer 3. So for this 19846 19846. Okay, so so our basic aim is here to shift it the maximum element at this position and minimum element to at this position to find the maximum difference. Okay, so first answer 1, we can simply calculate. We are just considering this as a maximum value, and we will find out the minimum part from minimum element from this side. Okay, so if minimum element is coming at any position from this left part, we can simply rotate the list and we can shift it to at a first position. Okay, so we are calculating the answer 1 using 6 minus 1. The first possibility. Okay, second possibility, we are just considering this as a minimum and we are finding out a maximum element from this side. Okay, so we are just simply calculating this is the maximum and we can simply rotate clockwise of so three after 3 rotation this 9 will be shifted at the last position. Okay, and simply 9 minus 1 will become 8. This is the second, but the another possibility is also there. If maximum and minimum element is available at the in the middle part. Okay, maximum and minimum element are available in the middle part, and there also so there is also a possibility to shift it that elements. So here the maximum element at the last position and the minimum element at the first position. So there is a possibility if the both elements are coming in the middle, but we after rotation they can come of the first and last position. So how we can find out these things? So any adjacent value. So if you apply the rotation on this list, okay. So every time the last element and first element will be adjacent element. Okay. So if you rotate this, so for example, this 6 and 1. If you rotate this, so this 6 will come up before 1. Okay. That means each adjacent element can be come at the last and first position. But so how we can find out the difference? So simply those elements are coming at the first position in adjacent. Okay, so this is the first, this is the second position. After rotation, so this element will come at the last position, and this second element will come at the first position after circular rotation. Okay, in the clockwise rotation. Okay, so that means if we find out the difference between the in the each adjacent between the first and second element, so 6 minus 1. Okay, so that can also become at the first and last position. So there's no need to circulate. We can simply find out the difference between each adjacent. Okay, so first condition we have checked, last condition we have checked. Now just check for the remaining part if elements are coming in between. Okay, so if we are calculating the difference between 1 minus 9, because these 1 and 9 can also be shifted to the first and last position. Okay, so 1 minus 9 is minus 8. Same things we will check for this 9 and 8. So 9 minus 8 will be 1, and then 8 and 4. 8 minus 4 will be 4, and 4 and 6. 4 minus 6 is minus 2. So these all are the possibility that can come on the first and last position after rotation. Okay, so we are just simply find out the maximum of all these 4 values. So this is 4. Okay, and we have already checked with the 2 remaining possibility where we are getting 5 and 8. After that, we will compare the all these 3 and we will return the maximum of all. This is 8. 8 will be the answer for that. Okay, so you can also take the another example for this. So for the second sample like this, 4 and this. So 3, 2, 10, 8. Okay, so here we will check that what this is the 8, this is the maximum value, what is the minimum value? 2. Okay, so 8 minus 2, this is 6. And next one is 3, and what is the maximum value is here? So 10. So 10 minus 3 equal to 7. Because here we are finding max, so we can simply shift it to this 10 to on the last position after one rotation, this part. Okay, and the another part, this is the 3 minus 2, 2 minus 10, and 10 minus 8, all these three positions. Okay, so this is 1, this is minus 8, and this is 2. So maximum is 2. So we have three values, 6, 7, 2. So we will return this 7. Okay, 7 is the answer for this question. So this is the logic we are applying in the code. Okay, so this is the next loop we are using inside the for every adjacent condition, and after that we are returning simply answer, maximum of all the three possible elements. Okay. Okay, what is the yeah, okay, fine. Okay, we'll move to the second problem. Okay. Yeah, this is the okay. This is grid-based problem. Okay. Yeah, it's time to play. Yeah, it's time to play TikTok. But in a different way. Let's jump on the game. Okay. So I'm not reading the problem completely. You have already seen these problems in the assignments. So here some grid structure is given. Okay, so the size is given, rows and columns in the way. So you need to cut these grid in the rectangle way. Okay, so you cannot cut in the square way. Okay, I'm just explain with the example. So we have given one rectangle size. So for example, m equal to 2, n equal to 5. So this is representing a number of rows, and this is representing a number of columns. Okay, so I'm just designing the first structure. So total number of rows are 2 and columns are 5. Okay, so this is the m1 2, this is m1 2 3 4 5. So we can cut this grid from the line. Okay, so we can cut from here. Okay, in that way we can cut. We can also cut this in that way. Okay, but the after cutting this grid, our output should come in the rectangle piece. Okay, that should not be come in the square. Okay, and there is also there is one more condition is given. Each block is contain O value. Okay, so after cutting this grid, the no adjacent value in the cutting grid. Okay, so for example, if you are cutting in that way, so no adjacent value should be same. If we are cutting, for example, if you are cutting the size 4 like this, we are cutting this grid by size 4. Okay, so we are getting 4 field with the all 0. Okay, now we need to change this O to X. Okay, O to X. So so after changing this O to X, so for example, if we are changing this X and this X, so now you can see that after changing this, no adjacent value are same in this cutting grid. Okay, so how we can cut this grid in that way? So we need to change this O to X, that value should be minimum. So for example, if we have only one dimension, okay, so 1, 2, 3. Okay, so for the size is 1/4. Okay, now all O are there. So for example, if we are not cutting, so how many chains we need to done in this grid? So we have to change at least 2 O. Okay, so we have to change this O, and after that we have to change this O. So to fulfill the condition of the problem statement, so if we are not cutting this size 1/4 and we are getting this rectangle piece, so we have to change at least 2 O to X. So here the value is 2. Okay, if we cut into 2 pieces, so for example, if we cut into 2 pieces, still we have to change at least 2 O to X. So answer is also 2. Okay, we cannot cut in the 3/1 piece. Okay, so for example, same things, if we are cutting this first grid, and so here this size is 3/1, but after that only square bracket is remaining. So this is not the correct way to cut it, because the output should not be come in the square cut. Okay, so this is incorrect way. Okay, we can cut in that way, so we will get always square, sorry, rectangle grid. But our changes from O to X should be minimum. So how we can find out this value? So our output should, we are calculating the output, this 2. Here we need to change 2 O to X, same for the this way, but this value should be minimum. Okay, so I'm taking the another example of the 5 cells. For example, all are 0 initially. Okay, so for example, if I am not cutting this, so how many O to X change is required? So for example, if I am changing this, okay, then this is the one possibility. If I am not doing in that way, if we are changing, so for example, if I'm changing this O2, then we have to change this one also, and then we have to change this. Okay, so this is also one possibility, but here we are changing 3, and here we are changing only 2. So we need to, our answer should be minimum. So cut the grid in that way, so our answer should be minimum. Yes. So how we can figure out the solution for this? So initially we think about the brute force approach, just try the random things, but this problem is basically totally depend on the mathematicals. So just take the small size first. So for example, we can take the this is the constraint is given, the size will be greater than 1. Okay, so for example, this is the smallest size of our grid, all 0 are there. Okay, so if we have a grid after cutting, or if this size is given, so if we have a grid of size 1/2, okay, so we at least we need to change 1 O to X. So for this size of input grid, we need to change at least 1. There is no possibility lower than 1. Okay, so this is the 1. For example, if we have a 3 size, okay, so how many, so what will be the minimum possible value for this time to change O to X? So if we are changing first O to X, we have to also change for the last one. Okay, so that is the 2. But if we change middle O, so our condition is also satisfied. Now the adjacent are not same. Okay, so the answer is 1 for that. Okay, but
Hello,
yeah,
sir. Professor Neeldhara Mishra is not taking the.
no, in this term actually she is not available to interact in the session. Hello.
Okay.
Okay. Yeah. So this is the second possibility. If we have a size 1/3, so at least one change is required. But if we increase the more size, so for example, if we are increasing by 1/4, great. Okay. So here 40 are there. So what is the minimum changes required? O2x to fulfill the condition. So here at least two changes required. Okay. This is the minimum possibility. Okay, so same things if we divide this into a two grid by of 1/2 and 1/2 size. Okay, so this is coming into this first category. Both are coming into the first category. Okay, so that means if we have a size of the 1/4, so we can we can once again divide that into a size 1/2 and 1/2, and we are getting the same answer. Okay, so after dividing two grid, we are also getting 1 plus 1 2, and same for 2. Okay, so for example, if we have a 5 size, we have already seen here. Okay, so now what is the minimum possibility here? So you can see that if we cross 1 here and if we cross 1 here, so we are getting 2. Okay, so this is the minimum possibility. But same things, if we divide this 1/5 into a 1/2 and 1/3, so we can say that this is coming into this category, and answer is same. If we divide one more time of size 1/2 and 1/3, so here we are getting 1, here we are getting 1, and then 1 plus 1 is 2. Same answer we are getting from this size. Okay, so every size after this 1/2 and 1/3, we can divide further into a 1/2 and 1/3. Okay, so if we have a size 1/6, we can divide 3/3. Okay, so 6 size is given. For finding the minimum answer, we can simply divide 3 blocks, 3 rectangle piece. Okay, so for this size we need 1, and for the another size we need 1. So total 2 changes required. So after cutting this piece. Okay, so that means these two sizes are important to finding out the total number of changes in the size. So now the initial size is given in the problem in the first sample, for example 2 into 5. Okay, so what are the minimum number of changes required? Okay, 2/5. So we can simply count the possibility of piece of 1/2 size and 1/3 size. Okay, so these are the two possibilities. If we count the total number of how we can cut these full size grid into a total number of possible 1/3 size cut and 1/2 size cut. Okay, in this grid, how we can find out these things? So here size is given. So this is size is given 2, and this size is given 5. Okay, so what is the size of this columns? 5. Simply we can simply apply this 5. Okay, so what is the size of this, and divided by size of this rectangle is 3. Okay, so 3. So here, and this is the in the for the one row. Okay, okay, so but we have the 2 row, so we can also multiply by 2. So this is representing a floor value, so we will get the 1 into 2. Okay, so 2. Now that means we can cut this grid into a 2 1/3 piece initially. Okay, so this is the first one is the lower one, and second one is the upper one. Okay, this is the first cut. After that, after counting this value, so we will also reduce the size of our rows and column. Okay, so initially we will reduce the size of our column. So now we have reduced the one, we have cut the one piece of 3 size. Now we will reduce the size 5 minus so simply we can say that 5 minus 1, sorry, not 1, 3. Okay, so now that our Total number of columns are remaining 2. Okay, and but number of rows are still 2. So our remaining problems are pending for size 2 by 2. Okay, we have calculated the possible 1 by 3 grid in the first part. Then what is the remaining grid is of size 2 by 2. Same things we will apply on this part. Now the size is less than 3, so we will check for this second smaller value. Okay, so same things. Now this column is 2, so 2 by 2. So how many rows are there? 2. Okay, so this is 1 into 2. That means we can also cut 2 grid of size 1 by 2. So here 2 grids of size 1 by 3 and 2 grids of size 1 by 2. Okay, and each grid we need only one change. So here we need one change and here we need one change. So here 2 grid are there, so total 2 changes required, and here 2 grid are there, total 2 changes are required. So answer is 4 for this complete grid. So we need to calculate this number of size of 1 by 2 blocks and 1 by 3 blocks. Okay, so we can solve this part using a mathematical way. Yeah, so this code is given. So the first possibility, so this is the size X, this is representing a number of rows and columns Y. Okay. Initially we will check for the what is the number of K. So this K is representing a total number of grids we are cutting. Okay, so we are cutting of size 1 by 3 or 1 by 2. So we will increment the numbers in the K value. So first things we are checking for the X number of row. Okay, so how we can divide the number of row by 3 and we will multiply by Y. Okay, so the other possibility is also there. For example, if we have a number of row, so like this 4 by 4 grid. Okay, so So 1, 2, 3, 4, and 1, 2, 3, 4. So here X is 4 and Y is also 4. Okay, so first we will check how we can 1 by 3 of size grid we can cut from this. So we will check for the X size. So X divided by 3 into Y. So what is the size of X? 4. Okay, so 4 divided by 3 into Y. Y is 4. So now this is 1 into 4. That means 4. So what is the, so 4 we are cutting means we are cutting these 4 grid. Okay, so this one is the first, second, third, and fourth. Okay, now what is the remaining size of our X is 1. Okay, X is 1 and Y is 4. So same things we will check for the Y. Now we will check for the 3 value. Okay, so same Y 3 into X. So here size is 4, 3 into X. Now X is 1. Okay, so 1 into 1. So that means we can, from this side, this is the remaining part. In this part, we can cut only one piece of 1 by 3. Okay, but this is not the true condition, so we cannot cut in that way. So we will check the another condition for this 2 by 2 size. Okay, so we will check for the another. So 4 by because after cutting this, we will get the square. This is not the correct. Okay, so same things we will check for the 2. Okay, so 4. Okay, so this is condition for the 3. If this is not the correct, we will check that what is the 4 divided by 2 into X. So what is the X? Okay. Okay, now 2 into 1. So that means we can cut into a 1 by 2, 1 by 2, 2 piece. So now there is no part is remaining. So that means 1, 2, 3, 4. So 4-way change is required on these all three, 1/3 size, and 2 is required for the lower part. Okay, so 6 is the answer for this. And here we are getting this by logic. So initially we are checking for the size, what's k equal to x floor division with 3 into y. Okay, after that we are reducing the size of x because we have already cut from the x. Now we are reducing the size of x, and then we are checking for the from the y side. Okay, same things we are checking for the y, and now we are reducing the y size. Okay, after that we are checking here what is the remaining part size. Okay, so after reducing x and y, if x into y is equal to 2, okay, so that means if x into 2, so that condition can be only true if x size is 1 and y is 2, or y is 1 or x is 2. So that means we have only one possibility of the 1/2 grid. Okay, so we are increment by 1, k plus 1. If we are getting x into y equal to 4, so that means x equal to 4 and y equal to 4. Sorry, x equal to 4 and y equal to 1, y equal to 4 and x equal to 1, and x equal to 2 and y equal to 2 in the all cases. So we will increment k plus 2. So after checking for the 3, we have these 3 possibility like this, okay, and like this, and one another is this. Okay, here x equal to 1 and y equal to 4. Here x equal to 4 and y equal to 1. Here x equal to 2 and y equal to 2. So all 3 conditions, the answer will be 2. Okay, we can cut 1/2, 1/2. Same we can cut 1/2, and same we can 1/2, 1/2. Okay, so we are increment by 2 value here. Okay, and if the any condition is not true, we will return k. That means if our grid is completed by the checking of 3. So for example, if we have given like this, okay, so we can simply cut 1/3 piece upper piece and 1/3 lower piece. There is no remaining part. Okay, so in that case, we are directly printing k. So in that way, we can directly calculate the total number of minimum change required, O2x. Okay, so this is the solution for B1 problem 2. Any doubt? You can write in the chat. Okay. Okay, thanks. Okay, so now B2 problem. Okay, problem 2. Sorry, B2 problem 1. Yeah, here one problem is given. Ant-Man is stuck in the EV layer. In front of him, it is a stairway with n steps. Okay, so this is the how many steps ant can be achieve with the limited leg size. So this problem is given the B2 problem 1. So here the length of the leg is given in the each test case. Okay, and also the stair size is given in the array. So this is the first input, yeah, and number of steps and number of different length of the legs possible. Okay, so number of steps are there and number of lengths. So this is the size of legs. So we will check the answer for each legs. And first line is contains the number of test cases. Okay, second line contains the number of parameters. So this is the okay. This is the stairs steps. Okay, I'm just copying the one. This is two test case for. So second week is related to the sorting and searching thing, where the binary search is also discussed. So how we can achieve the solution using the binary search for this problem. So any problem can be solved with the different type of strategy, but we are discussing the efficient approach for this. So here two test cases are given, okay, and the size of steps, and this is the total number of lengths. Okay, yeah. So steps means this is the steps means. So for example, if we are starting from 0, so in the first stairs length is 1, okay, and next is size is 2. This is 2. Next steps is 1, and next is 5. Okay, 5. This is the stair length, which is at the each step. We are starting from 0, and of the height 1 we can reach at the first stairs. Then second height of the steps is 2, third height is 1, and fourth height is 5. So this is the input given, and the next line, the size of the legs is given. For example, if we have the size 2 for the leg, so what is the maximum height we can achieve in the stairs? So for the two heights, we can simply reach at this step easily because the height is 1. Same things we can also reach at this step, okay, with the height 2, and same things we can also reach at this step. But we cannot achieve this this height because here the height is 5, but our leg size is 2. Okay, so this we cannot achieve. So what is the total height we can achieve? 1 plus 2 plus 1, 4. Okay, so this is the problem basically, and we will check for each leg size. Okay, we will check for the 1. So for the first leg size 2, maximum height is possible. So this is 2 for the 2 size. Answer is 4. If our leg size is 1, so we can reach at the first step, but after that we cannot pull up. Okay, so the next step size is 2, so we cannot achieve this. Okay, so we have to stop at this point. So maximum height we can achieve by only 1. Okay, so next is 9. So our leg length is 9. So simply we can reach at this steps. We can again reach at this step. Same things here. Okay, after that the size is 5, but our leg length is 9. So we can also reach at steps. So total is 9. Okay, same for the 4. So 4, first step is clear. Now second, third, but we cannot achieve after that because the leg size is less than this 5. So total size is 4. Same for the 10, we can achieve 9. So this is the output for the each leg size. Okay, but how we can apply the binary search on this, and how we can simply improve our solution at time. So we can, so for each steps of the stairs, so we have given this 1, 2. Okay, so I'm just representing that another way. So 1, 2, and 1, and 5. Okay, so now we will create another list for the each steps. So for example, if we are starting, we will just check for that. So this is the 1 step. I am just giving the identification for each steps 2, 3, 4. Okay, so we will calculate the simple value for 1 step. What is the minimum length is required to reach at the first step? Okay, I'm just representing by a C. This is the possible value, C of I. Okay, so for the first step, reaching at the first step, what is the minimum length is required? 2. Sorry, 1. This is the minimum length. Okay, and when we are reaching at the second step, so what is the minimum length is required? So we can simply check this by maximum of this value and the previous value. Okay, what is the maximum value of the this step 2 and what is the maximum value of previous value? So what is the maximum of among all these two? 2 and 1. So 2, if we our leg size is 2, we can achieve this second height. Correct? Because our leg size is 2, we can reach easily this one and we can also achieve this one. So for till second steps, we need to leg size minimum is 2. Okay. For the same next, if we want to reach at the this step, third steps, so we will just check the maximum value of this one and previous one too. What is the maximum value of these two? Is 2. Okay. Now same things. So that means we can reach this third step if we have a minimum length is 2. Same for the 5. Now for the this complete this fourth steps, we need max of this 5 and the previous one 1. Okay, this is the 5. So that means this is the minimum height is required of the leg, so we can reach at this fourth steps. So we will just simply calculate this value for each steps. Okay, so I is the 1 2 3 4, and same time we will also calculate the s value, so that is containing the record if we are reaching at the first steps. Okay, so for the first step, what is the maximum value we have achieved? Okay, so till first step we have achieved 1 length. Till the second steps, so 1 plus 2 is 3. What is the maximum achievement at the second step? 3. Okay, so this here we are basically calculate the height till the second step, total height. Same for the next is 3. So 1 plus 2 plus 1 is 4, and same for the next one. This is 9. Okay, so after calculating these two value, we can apply the binary search method on this list. Okay, actually this list is containing a minimum length size is required. So now we have one list 1 2 2 5. Okay, and now leg size is given. For example, initial leg size is 2. Okay, so so we have this list. We will directly check the middle element. We will directly check the middle steps. We will simply apply the binary search approach and we will directly check the middle steps. So if size is 4, so 4 divided by 2 is the, so for example, if we are considering the index 0 1 2 3. Okay, so we are getting, so this is the 0 plus 3 by 2. Okay, so 1. That means we are getting this as a middle element, or middle element we can calculate by the total length of by 2. So 4 by 2. In that case, we will get this another middle element. Okay, so we can use any formula to calculate middle element. So for example, if we are calculating in that way, so we are getting middle this element. Okay, this is the second step. Okay, so step means 1 2 3 4, and we are directly checking for the second steps, and we will simply check our leg size is given 2, and we will calculate the value of this, what is the minimum length is required at this steps. Okay, so at till this step, if this value is equal, okay, this equal, or our length is smaller than, we will reduce the left part and then we will check for the right part only. That means we have reached at this, we can easily reach at this step. So there is also a possibility to reach on the another right side. Okay, so our leg size is 2. We are checking for this is first step. Okay, second step, sorry, second steps. So here the minimum length of leg is required to reach at this second step is 2. So that means we can easily achieve this, but there is also a possibility to achieve the right part. So we will ignore the left part, because at this step we can reach. So now we will check the right part. Okay, so now the remaining part, same things, we will just change these index left and right. So in that way, we will change the 1 plus 3 and same things divided by 2, and we will get 2. Okay, so now we are checking this middle value. Okay, so in that case, we once again we will check what is our leg size 2 and what is the minimum length leg is required to reach this step is 2. The value is equal. That means we can also reach at this step. So now this one is the another part. Now that means we can reach in this part. Now we will check on the remaining part. So same things are, now we have 2 and 3. This is the left and this is the right, and we will just add 2 plus 3, 2. So this is again 2. Okay, so same things. Okay. Now we are checking for this size. That means we have already checked. Okay, we have already checked. Yeah, if we are okay, we have already checked. We increment our left part. So this part we have checked. Now we will check for the right. So left and R are same, 3 plus 3. So now we will check for this part, and this is not possible because here size is required 5, but our leg size is 2. Okay, so in that case, we will return the last possible value. So at this step, we can reach, and we can directly read the value of the third step. So third step, the condition was true, and we can directly read the third step value from this S list, and we can directly return the answer for this 4. So this is the achievable height with the leg size of 2. Okay, so in that way, after creating these two lists, we can apply the binary search on this list and directly check that the middle value, this step is reachable or not by this value. Okay, this is also representing a minimum length is required to reach till this step, third step or this third step. Okay, so in that way we have created we can create the solution for this problem. So we can also take the another. Okay. Yeah, this is the solution for this. So here we have created one list C and S. We just need the value directly from the our A list. This A list is representing the steps value and B list is representing the leg size. Okay. So we are updating this C by using this loop, by using this formula max of Ci minus 1 comma Ci. So in that way, we will update the C, and each value of I, we can figure out the minimum length of leg is required to reach at this step. Same thing, if we are reaching at any steps, we can directly check the total height value till that steps. Okay, we are maintaining this record inside this Si plus Si minus 1. Okay. After that, we are applying simply binary search method. So we are just starting from the L value to the -1 and R value to the N. And if R minus L is greater than 1, we are checking the middle steps. If this middle step is reachable with the leg size, this is the leg size value is given. If this middle step value is reachable using this leg size, we will shift our, if this leg size is smaller, then the steps leg size required. Okay, so we will reduce R equal to M. Otherwise, we will shift our L equal to M. So same things, we are just ignoring the left part or right part using the binary search. So for example, if we have another number, so this is type is required. So this is the total step. So for example, this is the steps. Okay, so till now 1 2 2 3 3 3 5 5. Okay, so this is the C value. Okay, C of I steps. This is the 0. Okay, now we can simply, so for example, if we are getting M equal to 3, okay, if our leg size is, for example, 5, or not 5, 2. Okay, our leg size is 2, and we are directly checking the middle elements. Okay, so we are getting mid position like this. So here we are checking that we are getting 3 leg size required to reach at this step. Okay, so in that case we will remove this part for checking, because we cannot reach at this steps using leg size 2, because till this step 3 leg size is required. So in that case we will remove this part to check, and we will check for the remaining part. Okay, now in this part we will check again. We will once again we will calculate the mid. For example, if we are getting this mid position 2, here 2 leg size is required. Now this is true. If the value is equal, that means the possibility is available on the right side. This part is already clear. Okay, if we are reaching at this step, so there is no need to check on the left side. Now possibility is available on the right side. Okay, now we will check for this part. So after checking first step, then second step, then third step, we will check for this one. Okay, so this is also achievable because size is required 2. Okay, now our list is searching area is completed, so we will directly return. So for example, this is our third step. So 1, 2, 3, third step. So we will directly return the total height of this third step from our another list, S list. Okay, so this is the concept we can use to solve this problem using the binary search. Okay, so this session is also recorded on the YouTube. You can see, or we will also edit the link in the portal. Okay, so this is the B2 problem 1. I think it is clear. Any doubt? If you have any query, you can write in the chat. Okay. Okay, I'm just explaining again this with the another example. One second. Some test is input is sphere sizes. Okay, I'm just creating a new test case. Okay, so for example, if we have a steps, total number of steps like this. So 1, 3, 4, 3, 4, 2, 5, 3, 4, 6. Okay, so this is the steps, okay, of the stairs. So like first stairs height is 1, then second stair height is 3, and in that way. Okay, 3. So you can imagine in that way. This is the steps of each. After that, we have given leg size. Okay, so there is there is a list where the leg size is given. Okay, so for example, we have a 2, 3, 4, 5. So we will check for the each leg size. What is the maximum height we can achieve using this leg size 2? Okay, so there is one linear ways available, so you can directly check from this post. So I think the multiple possibilities there if you use the brute force approach. So for leg size 1, okay, so 1 leg size you can achieve this. After that you cannot achieve this. Okay, so you can directly find the answer 1. But 3 leg size, what is the another possibility? So 3 sides here, this one you can achieve, then after that 3 you can achieve. So 4, yeah, this is not achievable. Okay, in that way. Same for the 4, you can achieve this 1. Okay, 1, 3. So this is the linear way to check. But how we can improve this? So 4 size, you can start from this value is smaller, this value is smaller, you can achieve now this value is greater than. So this is not achieved. After that you cannot achieve the next height. So for example, if this input list is given in the very large list is given, so if you apply this linear way, the complexity will be n. Okay, but how we can improve this? How we can apply the binary search logic to check this? So we will create another list using this steps data, and for each step, so for the first step, so if we are checking for the first step, okay, so just consider that this is the first stairs of size 1. Okay, and now we will create another list for this. So this is the size required to achieve this first stairs. The size, what is the length, minimum leg size is required to achieve this first step? 1. Okay, I'm just reading this one value. Okay, so this is the one value for this. Now just consider the second stairs, this where the size is 3. If we are starting from the 0th position, what is the minimum length size is required to achieve this second stairs? 1 size you cannot achieve, 2 size you cannot achieve, but 3 size you can easily achieve on the both stairs. So you can easily pull up this stairs and then this stairs. If your leg size is 3, you can reach at this steps. Okay, so minimum length is required to reach at the second steps is 3. Okay, we are creating another list where we are calculating the total length at the till the steps. So this is the second step. So first step total length is first. If we are reaching till first step, total height is 1. If we are reaching at the second steps, total height is 1 plus 3. Sorry, this is the step size. 1 plus 3 is 4. Okay, so now consider the third stairs. Okay, where the size is 4. So to reaching this third stairs, okay, what is the minimum length is required? If your leg size is 1, you cannot reach at this step. If leg size is 2, you cannot reach this third stair. If leg size is 3, you cannot reach. Okay, you can reach till here. But if your leg size is 4, you can reach at this steps. Okay, so for the third step, where the stair size is 4, so what is the minimum leg length is required? This is 4. And what is the total height till here? 4 plus 3 plus 1. So this is 8. Okay, so in that way we are creating this list only one time. Okay, for the next 3, same for the next. So till the 4th steps, what is the minimum length leg is required? Leg length is required. If your leg length is 1, you can reach only 1 steps. If your leg length is 2, you can reach only 1 step. If your leg length is 3, you can reach till the second steps, but you cannot achieve the third steps because your leg length is lower than this 4. Okay, but if your leg length is 4, you can also achieve this one. So 4, so here height is 1 is less than 4, 3 is less than 4, 4 is equal to 4, and 3 is less than 4. So that means if your leg size is 4, you can reach this 4th steps. So for 4th step, minimum leg length is required 4. And what is the total height till now? Is 8 plus 3, 11. Okay, so in that way we are creating the one list. See, same for the next step. This is 4. Now next step size is 4, and if your leg length is 4, so you can achieve this these 5 steps. So that means for the 5th step, if leg length size is, so this is the minimum leg length is required to reach till 5th steps, and the total height till the 5th step is 11 plus 4, 15. Okay, so in that way we are creating this new list C. So it is maintaining a record at each steps. To reaching at this steps, what is the minimum length leg is required. This list is maintained. Okay, so for the next two, so definitely previous one is the 4. So for next one is so the value cannot be reduced by the previous value, because if the previous till the previous step the leg length is required, minimum leg length is required 4. So without 4, so for the smaller value of the 4 you cannot reach at the next 6 step, because you are coming in the from the ground position after using the all stairs. So same things for the 6, 4 is required. Now size is 2, 15 of 17. Next one is 5. Now here this the stairs length is 5. So now previous one is 4. So that means the this stairs length 5. You require 5 length at least. Okay, so 7, 5, and 17 plus 5 is 22. So in that way we will maintain this list. After that, for each test case, so for each leg size, so there is no need to check sequentially from the starting. You just apply the binary search logic and directly check the middle condition. So I'm just taking, okay, so 5, 1, 8, then 5, and this is 23, and next one is the 5. Once again, it will remain the 5, 9, and 5, and 23 plus 3 is 26, and 10th stairs is also 4, so minimum required is 5, and 20, 30. So I'm just considering till 10 stairs. Okay, so for I'm checking for the 2 value. Okay, so we will check the middle step. So we have 10, we will check for the 5, or we can simply calculate 10 by 2 equal to 5. So in that way we are checking directly middle element. Okay, so if middle element is possible with the length 2, so this value is leg size is 2, we will directly compare this value by this C value for the 5th steps. Till this steps minimum leg length is required 4, but our leg size is 2. That means we can ignore all this right part, no need to check. Okay, now we will check the only this part. So in one step we have ignored half of the elements, half of the size. Okay, now we have size 4 and we will check the middle part. So for example, if we are checking 2, second step, so for second steps the minimum leg length is required 3, but our leg size is 2, so this is also not achievable. So that means we will ignore this part. Now we will check only one step. So 2, now the leg size is 1, this is smaller than, that means we can achieve this. So here the total height we will directly return from this step 1. So for leg size 2 we can achieve only one height, and we are calculating this value only 3 steps, first middle, then second middle, and then the last. That means we can find our solution in log n step. So this is the efficient way. If we have a, for example, 1024 stairs. Okay, so using binary search, you can directly reduce by 512, then you can directly reduce by 256. So every time you will ignore the half either of the left part or the right part. Okay, so in that way, in the log n step, so here n equal to 1024, so log n value will be 10 for this. So in 10 steps, you can check your solution. You can check the solution, how maximum height you can achieve with the leg size, particular leg size. Okay, so we will calculate, we will apply binary search for each leg. So 3 size, we will directly check the middle. So middle size is required 4 leg size. So this is not achievable. We will reduce the right part. I will check for the another middle. So 3 is available here. So that means we can achieve this height. Okay, with the 3. Now we can ignore the left part. Now we will check for the right part. Okay, so right part, we are calculating for the this value here, the value is 4. Okay, so this is not achievable. We will ignore the right part now, and then we will consider the this part. So this is the last stage where our condition is satisfied. So 3 is equal to 3, then we can achieve this height, 2 steps. And till 2 steps, total height is 4. We will directly return the answer 4. Okay, so this is the way we are using here. So we are creating the two lists C and S. After that, we are applying the binary search. If our leg size, so this is the leg size is given in the list. So in every case, so for I in range L, so this is the leg size. For each leg size, we are using the binary search approach. If our leg size is smaller than, okay, so we will shift our R value, and on the remaining part, in the another condition, we will shift our L value. Okay, so this is the binary search approach. If you are not aware of the binary search approach, just go once for the binary search. How we can improve our efficiency in the code, solution code. So I hope this is clear. Okay. Okay, so last problem of the B2. Yeah, problem 2. So here the scenario is the similar type of this. So yeah, okay. Here there's one factory, number of employees are given and number of jobs are there. Okay, and if employee is skilled on the job, it takes 1 hour, and if it is not skilled, then it takes 2 hours. Okay, so total number of employees is given, and this skill information is also given. And just figure out that what is the minimum time is required. Okay, so I am just reading one test case and explain the problem. Okay, so this value is the test case. So first value is representing a number of employee, m equal to 3, and this is representing a number of employee 1 2 3, and second value is representing a n equal to 5. This is representing a number of jobs. So I'm just giving the ID 1 2 3 4 5. Okay, so this is jobs and this is employee. Okay, now this another array is given with the details of for the each job, which employee is skilled for that job. Okay, so for this job, first employee is skilled, so that means this first employee is skilled for the first job. Same for the second job, first employee is skilled for that. Okay, and for third job, second employee is skilled. Okay, so for the next job, fourth job, third employee is skilled, and for the fifth job, second employee is skilled. So this is the employee ID is given. Okay, for the each job, this is the job ID. Okay, for each type of job, which employee is skilled, that data is given in the input. Okay, so what is the minimum time is required? So so these employee can work parallel. Okay, so all these 3 employees are there, so 1 2 3. Okay, and we have 5 jobs, so what is the minimum time is required? So for example, if we apply, so how many, so this one, okay, so 1 2, okay, 1 2, and this is the 2 2 and 3. So we can also figure out this Okay, if we will solve this manually, so what will be the answer for this? So for example, 1 2. So if first employee perform two jobs, 1 and 2, so 1 hour is required for this and 1 hour is required for this, because this employee is skilled in 1 and 2 job. He will take uh, at, at least 2 hours for this. Okay, for the second job, same things. These two employee are there. Sorry, two. Okay, sorry. Yeah, this one. So same time, second employee can complete 3 and 5. Okay, and third employee is skilled on the fourth job. Okay, so only 4. Yeah. So this is the data is given. So for example, parallelly, if the we select the job for the each employee. So first employee is performing the first job, second employee is performing the third job, third employee is performing the fourth job. So it will take 1 hour to complete all 3 jobs. Okay, and for the next 1 hour, same things we will use. Second jobs will be performed by first employee, fifth job will perform by second employee. So it will take 1 hour. So total minimum hours is required 2 hours for this test case. Okay, now I take the another example to understand for this. Okay, so now here employee are 2, 1 and 2, jobs are 4. So 1 2 3 4, and each job the first employee is scaled. Okay, so that means we have 2 employee. So that means in parallel they can perform 2 tasks parallelly, 2 jobs parallelly at the same time. Okay, so we can select the any jobs which is the skilled by the in one employee. There's no 2 is not skilled in any job, so definitely it will take 2 hours at least to perform any job. Okay, so but the one employee can one job at a time, so 1 hour is required. Same if we perform the second uh, job, so 2 hours is required to complete at least 2 jobs. Okay, but same times we can give one job to second to complete in 2 hours. Okay, so we can give any. So for example, if we are giving third job, so it is the second employee is taking 2 hours for that, because he is not employee for that job, he is not skilled for this. So at the same duration, first employee can complete 2 tasks. Okay, so that means for 3 jobs we can complete in minimum 2 hours. After that, one job is also remaining, so we can we can give to the first employee. Okay, so it will take 1 hour. If we gives to the second, once again it will take 2 hours, so total duration will be increased. So now this is the assignments to reduce total hours. So here 2 hours is required, here 1 hour is required, so at least 3 hours is required. This is the minimum. If we gives in the different way, so for example, if we give the first job to this one and one is second, so it will take 2 hours. Then once again 1, and then we give to the another job 4 is also to 2, so it will take 2. So 2 plus 2 is 4 to complete all the tasks, all the jobs. Okay, so we will schedule these things in that way, so total minimum hours is minimum. So how we can identify perform this? We can also use some binary search concept to solve this. First I explain the concept here. So we will calculate the minimum time and maximum time possible for that job. Okay, so for the first test case, so I'm just taking the first test case, 3511232 113 2, 1, 1, 2, 3, 2, 2, 3, 2. Okay, and 3, 5. So this is the employee details 1, 2, 3, and this is the job 1, 2, 3, 4, 5. So we can calculate the maximum possible time if any employee is not skilled for any job. Okay, so what will be the time, maximum time to complete all the jobs? So for example, if 3 is there and 5 jobs is there, so what is the maximum possible time if any employee is not skilled? So we can simply figure out this. So 5, total number of jobs are 5, and divided by 3, multiply by 2. Okay, and we can also add some time. So we can also add 2 hours or any constant value more than 2 or equal to 2. So like this. Okay, so so 5 floor division 3. So that means this is 1 into 2 plus 2. Okay, so 2 plus 2 is 4. So how we are getting this value? So at least 3 employees are there, 5 jobs are there. So each job, 3 jobs can be completed in parallel by all 3 employees. Okay, so all the job 1, 2, 3, 4, 5. So all 3 employees can perform 1, 2, 3. These are the employees. So 1, 2, 3 we can assign. So these hours are required 2 hours. Okay, so we are calculating this using floor value multiply by 2. Okay, so floor value we are getting 1 here and multiply by 2, 2 hours is required. After that, the remaining value we will get. So 3 is completed. Now remaining value will always come with the less than 3. Okay, because we are dividing by the 3 here. So now 2 are pending. So next 2 is also can be possible parallel by 2 employees. So it will also take 2 hours. So this is the maximum possible time, 4 hours is required if any employee is not skilled. Okay, minimum time is required 0, we can take any 0 and 1. Okay, so this is the maximum here. First step is we are calculating the minimum time and maximum time. Okay, and another information we will also collect that. So each employee, how many jobs he is skilled. Okay, so first employee, so just check that where is the record, this one. Okay, so 1, 2. So first employee is skilled in 2 jobs. Okay, second employee is skilled in 2 jobs. Third employee is skilled in 1 job. So its value can also be a 0. Okay, so we will count this value. Okay, so using this information we will calculate the all possibility what is the minimum time is required for each job. So for this information, so that means if this employee complete all the jobs, all the skilled jobs, so minimum 2 hours is required. Okay, so for he is skilled in 2 jobs, so 2 hours at least is required to complete their 2 jobs. Same for this employee, 2 hours is required to complete the skill jobs. Okay, and this is only a 1, so 1 hours is required to complete this by 3. So total time is required 2 hours. So this is also a sequential way. Same in the parallel way, we can also use this employee and we can also use this employee. So minimum 2 hours is required. Okay, so how we can apply the binary search on this? So this is the input test case. We are reading the data. This is the n value, number of employee, m value, number of jobs, and this is the skilled information in the array. After that, we are calling this function. Now we are creating a counter for each employee, how many jobs he is skilled in. So we are increment by 1 well for each employee. After that, we are just start. So we want to use the binary search approach in this. So we are just initializing with the first minimum value and maximum value. Okay, So minimum value we are giving just 0. Okay, so if okay, so this is not possible, but for using binary search we can take 0 value. Maximum time is required. We can simply calculate using this formula, and we are adding some more constant value. We can add 2 also, but we are adding some extra value inside this. So this is the next. Okay. So this is the minimum and maximum time. After that, so we are getting two boundaries, 0 and maximum. So that means this is the boundary, for example, 0 and max. This is the time. Okay. So maximum time is required this one, and minimum time is required this one. So now we will check for the middle time. So for example, this value is 0 and this value is 10. This is the maximum time. Now we will check for the 5. Can we complete all the jobs in 5 times? Okay. If this is not possible, if all jobs are not possible to complete in 5 times, we will ignore this time period, and now we will calculate the middle part of this one. Can we complete all the jobs in 7? Here we will take the integer value always, because our jobs can be complete either in 1 hour and 2 hours. Okay, so decimal value is not required, so we will always take the integer value. So we will check for the 7. If our all jobs are not possible to complete in 7 hours, so we will not check for this part. Now we will check for the middle part again. Can we complete in 9? In that way. Okay, so this is the approach we are using in this problem. So using this, we are calculating the middle time by maximum time plus minimum time flow division by 2. We are using this because we are getting the integer value in the hours. So for this times, how many jobs we can complete? So we are calculating this value using in this variable 0. So now we, for each employee, so this loop we are running for the each employee, and we will check that how many jobs we can complete in this time duration. Okay, so for example, so here this formula we are using, this is the min value of the time. What is the minimum time we are taking, and what is the counter? So for each employee we are calculating this value. Okay, so for example, we are considering the first employee. We will check that how many hours are required. So so in the previous example, the first employee is skilled in 2 jobs, so that means he can complete 2 jobs in 2 hours. So that counter I value will return the minimum hours required. So 2 jobs is required. 2 jobs he can complete in 2 hours. So that means this solve will return the number of jobs basically he can complete. Okay, so minimum value we are returning here, and that value are representing a total number of jobs completed. Solve. Okay, so we can apply the, so I'm just explaining the code here, and then I'll take the example for this code. If solve is less than equal to 10. Okay, so for example, if we are getting this value, so first employee can complete only 2 jobs. Okay, so that means 2 hours is required to complete 2 jobs. If this time is smaller than the our middle time which we have selected, okay, then the remaining time is also available. So for the remaining time, how many jobs he can perform? So it depends on time minus solve, which is 2. And so this value we are calculating basically if our employee is not skilled, if any jobs are assigned for that. So definitely after the skilled job, it will take 2 hours for each job. If any job is assigning for that, it will take 2 hours. So for any employee, one employee skills in 2 jobs. Okay, so first job and second job. So he can complete in 2 hours. But after that, if we are assigning any other jobs which in which he is not skilled, so he will take 2 hours for one job. So that things we are calculating in the if condition. Okay, So for each employee, we are calculating that how many jobs he can complete. Okay. So this is the amount of tasks solved. So we are calculating the total number of this total number of amount tasks solved uh, with the with this minimum time, which we are taking for the middle element, middle time. Okay. So in this duration, what are the number of jobs are possible to complete? We are calculating. So if this number of jobs are greater than or equal to m. Okay. So for example, in this diagram, so if we have total number of jobs m equal to 5 and n equal to 3 employee, and we are just consider that maximum time is 10 and minimum time is 0, and we are checking for 5. Okay. So we will check that in the minimum time of 5, so how many jobs they can complete, these 3 employees can complete. Okay. So using the skilled information which we have counted inside the counter, so we will simply calculate the total number of jobs possible to complete within this 5 times. If we are getting the value total number of jobs equal to 5 or greater, okay, if we are getting total number of jobs equal to 5 or greater, that means this time is small. That means we can also check for the minimum time, because our all jobs are completed with this time, middle time 5. So that means if we can complete all of our jobs in 5 times, that means there is no need to check on the higher side. Now we will check on the lower side only. So there is a possibility we can also complete all the jobs in 4 times. Okay. So we will ignore this higher time possibility, because in the 5 times we can complete our jobs, or we can also complete more than this 5 number of jobs. So there is no need to check for the higher side. We will once again check for the lower side. Now we will check for the 2 value. Okay. So we will ignore this part, and same time now we are reduced our time to 2. Now we will check against the same things. So within the time 2, how many jobs our employee can perform? So for example, within the time 2, our 3 employee can perform only 3 jobs. So that means in this time period, all jobs are not completed. So we will reduce this part, and we will check for the this 2 to 5 time, middle part 3 and 4. Okay. So same for the, now we will check for the 3 hours, and then check if our n is possible. So how many jobs are possible, how many jobs can completed in the 3 hours. If still we are getting less than 5 value, we will check for the right side. Now we will check for the 4. Okay. If we are getting equal value to 5 at the same time, now our problem size is reduced to 1. So if we are getting the same all 5 value satisfy condition at the time 4, so we will return the answer is 4. Okay. So this is the minimum time is possible where all job can be completed. So in that way we are calculating, we are applying the binary search approach for this. So this is the main part actually. So for each half time, here we are calculating the middle time, and we are just checking that in this time period, how many jobs are possible to complete by our all employees. Okay. So based on that information, we are just deciding the next maximum time or minimal time. We are reducing the problem size. Okay. If our amount of tasks solved is greater than our jobs, definitely we will set our maximal time to middle point, previously middle calculated point. If it is not possible, so we will set our minimal time to middle point, and after that we will return our maximal time as an answer for this. So this is the approach for B2 programming problem 2. Okay, just go through the ones from the, just take some input and go through this part. This solution is also available to you on your portal. The deadline is over, so you can also see the solution. Just go through the solution once, in some input, you will get some idea. Okay. So any query, question? So B3 deadline is 16th. So we will conduct a session on Saturday this time to discuss the B3 programming problem solution. Okay, so every week we will conduct one session for these assignments solution. Yeah, any query, any question? Or related to, if you have any another doubt in related to anything, you can also post on the forum, either on Discord or Google forum. Okay, I think there is no query. If this last problem is not clear, you can also discuss in the next session. Okay, so B3 session you can also discuss again. If it is not clear, first try yourself. If it is not clear, you can ask in the next session. Okay, any doubt, any query? Okay, I think there's no question. Okay, then we are closing this session. We will meet you in the next session again. So maybe this time our TA Sahil or Satvik will conduct the next session. Okay, bye everyone. Thanks. Okay. Yeah, Karthik, you can close.